Good morning, afternoon, evening. Welcome to our webinar on cleaning and disinfection procedures to enable pigs and poultry health management. My name is Elizabeth Rodriguez, and I work as a global pig and poultry senior marketing manager at Sea Lines and Ecolab Company, the animal health division of Ecolab. Today, we are committed to enhance your understanding on how these practices contribute to an optimal health management. We welcome our speakers, Professor Elias Hansiaras, Chair of Biosecurity at the University of Ghent, and Eileen Claes, Global Technical Service at Sea Lines and Ecolab Company. But before we dive into the content, let's cover a few housekeeping items to ensure a smooth transition for all the participants. Please note that all the participants will be mute during the webinar to ensure clear audio quality. To make questions, please use Zoom question and answers at the end of the presentations to ask your questions. All the questions will be responded after the second presentation. The recording of the webinar will be made available to attendees after the session. Also, you can click the Show Captions button to enable closed captioning. Thank you for your attention to these important details. And now let's move to the first speaker. It's a pleasure to me to introduce Professor Elias Hansiaras that will share important insights on how cleaning and disinfection is your early livestock success. Elias is a veterinarian by the University of Thessaly, Greece, with field experience and has been a member of the Department of Population Medicine of Ghent University since 2012. He became an associate professor and assumed the chair of biosecurity of animal production of the veterinary faculty of Ghent University, endowed by Sea Lines and Ecolab Company. He has conducted research on biosecurity, antimicrobial use, antimicrobial resistance, and production diseases. Besides Ghent University, he has worked in the field as practicing vet for the Flanders Research Institute of Agriculture, Food and Fisheries, and in animal and public health institutions in Greece. Elias is a diplomat of the European College of Veterinary Public Health with a specialization on population medicine. He's a member of numerous scientific networks on biosecurity and One Health, and also is the co-chair of the European Union Funded Cost Action Biosecurity Enhanced through Training, Evaluation, and Raising Awareness. Professor, the floor is yours.
Thank you very much, Elizabeth, for the nice introduction. I will start already by sharing my screen. And so the title for today's presentation is about cleaning and disinfection and how to use it as an ally for livestock success. So another title that I was, let's say, thinking and doubting which one of the two, and in the end I said, I'm going to have both, is how to use biosecurity to empower farmers, you as a vet, and to safeguard pig and poultry production. So the role of the vet, as we know, the role of the vet is evolving, of course, and is not just an animal doctor. It would be straightforward for a vet, but we are, of course, I would say a big chunk of our work is being advisors. I have there a third axis, a third box where I have a question mark, and I think there's another role of the vet that I believe you will agree with me that we have. So the vet, as mentioned before, is I would say a central point where, of course, it's responsible for animal health, is responsible for animal welfare. We have, of course, the links and the extensions of public health and what is related even to One Health. But not only that, but we're also consultants. We have to have a certain ability to break down data about animal production and make sure we give correct, let's say, suggestions and guidance and directions also together with the farmer. By providing this, especially focusing on animal health and animal production, we ensure economic sustainability for the sector. But it's not just that. Of course, the veterinarian's impact extends far beyond the farm gate. We have also, looking, let's say, outside the farm gate, we are about environmental protection. We must ensure that the products that we are administering and the compounds and all our, let's say, strategy is in line with the responsible use of waste management and to align with all the environmental goals that the farm and the country has. So for the role of the vet, as we know, a small triangle represents the curative vet. But of course, this has long not been the case. It's changing. And of course, we have the preventive role. Vaccinations took over and a lot about strategies to prevent disease. But of course, before even that, there's the biosecurity. It's a fundamental piece where you can apply and make also enable the farmer to have the third role, not just an advisor, but also an educator, because there it shows the strength of the veterinarian to guide, to effectively do biosecurity for the farmer. Huh? So we're saying about this word biosecurity, but let's define it. There are some numerous, I would say, definitions about biosecurity, but let's define it here as the application of a set of management, behavioral, physical measures designed to reduce the risk of introduction, establishment, and spread of pathogenic agents to within and from an animal population. So it's a big title. There are many elements there, but we need to remember it's management, but not just management, it's also behavioral. We need to convince the farmer, most importantly, the farmer employees, the personnel, to implement correctly the biosecurity measures. And of course, it's the physical measures, it's about design. And so biosecurity measures help prevent the entry and spread of infectious diseases, as we said, and it can be divided in two parts, in two forms, so internal and external. The external biosecurity, it aims to prevent the introduction of pathogens onto the farm. And the internal biosecurity, it aims to reduce the spread. So it's all the measures taken to prevent the spread of infectious agents within the farm. And while for external biosecurity, we have location of the farm, its categories like visitors and the Danis lock, or as we call it, the hygiene lock. And of course, all the strategy that we have about using quarantine when buying animals. And for internal biosecurity, the categories are include disease management, cleaning and disinfection, the provision of working lines, clear defined working lines, and of course the management systems like all in, all out that you're all familiar with. So is biosecurity important? I think you will agree with me that for each of these challenges that I address here, ranging from epidemic disease, legislation issues, endemic and zoonotic diseases, and of course reduction of antimicrobial use, biosecurity helps to address them. So in fact, and as it's been, I would say now a common, let's say, truth, is that biosecurity is and should be, in any case, the basis for any disease control program. And now defining a veterinarian's blueprint for biosecurity, because it's not the most straightforward of, okay, so what's in it for me? So to make like the blueprint to create these three distinct pillars, we have the conceptual pillar, the structural, and the operational. And for the conceptual is basically is to showcase our knowledge about understanding the disease transmission, about putting in the risks, and of course designing solutions, such as like how to avoid the disease entering the farm. For the structural part of biosecurity is how should the farm be prepared, or how should the farm be revised? What kind of works needs to be done? So it's our advisory role there. And for the operational pillar of biosecurity is mostly the educator part, because there it's about our role. For instance, we train by training farmers on cleaning and disinfection, and especially farmer employees, the personnel. So the thing is, we want to ensure that the protocols are followed consistently. And also by focusing on this pillar is we emphasize the importance of adapting the practices to the local conditions. So why cleaning and disinfection is important for you? It's important because, of course, it addresses three main concerns. It breaks the chain of infection in multiple steps. It's not just internal biosecurity, it also extends to external biosecurity. It's connected with many, let's say, critical control points, like even cleaning the trucks, even when the entrance, the people that enter the farm. Also, it's connected about the pathogen elimination. Antibiotic use, as we all know, is not as straightforward a solution as it used to be. Tools actually that go-to tools we have now, it's not antibiotics anymore, but it's cleaning and disinfection products. This should be viewed as our tools now, because it's not just, we should not think it as a product, it's more like a concept. Actually, this has been in a European project by interviewing numerous European experts when ranking alternatives on antimicrobials, the biosecurity, cleaning and disinfection and internal biosecurity in general was ranked as the most promising alternative on antimicrobials. And for the third, we have scientific evidence. It's not that much. It used to be not that much, but it's increasing. So the number of studies per year, I just made a brief. It's a presentation that it does increase the last years, and there has been nice studies, of course. So for cleaning, organic matter matters, as you know. So it has to do that when removing organic matter, it reduces greatly the bacterial, the viral load. And for that, just I want to show a small study that is a nice study that was done 10 years already now by Ghent University, by our unit, where we showed that before cleaning, the floor of a broiler house easily can harbor many bacteria, square centimeter. So you see the number there, but just applying the cleaning step, the number of bacteria dropped down 100-fold down. And of course, when done, the next step being here, it was the disinfection step. It went another 32 times down as a downfold, 30-fold reduction of bacteria. So the conclusion here, they have it also here as a point there, as a small thing to mention, is that if you apply good cleaning, this will result in the largest reduction of the germs. And secondly, you do a good disinfection to achieve a final reduction. So removing organic matter, so it reduces greatly the bacterial viral load, and also it exposes pathogens, because by doing correctly the cleaning step, you have the possibility, if you do it correctly, you also aim to reduce and remove, ideally, the biofilm. But what is biofilm? It's this dense accumulation of microorganisms, which is in a layer of products of biotic and abiotic surfaces. So why is this important? Because bacteria in the biofilm are less sensitive to disinfectants. So by having less biofilm, you also increase the efficacy of the disinfectant. And of course, you also need to consider the choice of your cleaning agents. It depends on the type of deposit, and also depends sometimes on what are we talking about, the construction materials that you have in the farm. So there are many things to consider when you're doing intervention there. Some small mentions to say that, of course, for poultry and for pig farms, there are differentiations, of course, depending also on the nature of the farming itself. So for poultry, you have the litter management, some considerations about the egg contamination, and of course for the drinking water hygiene, which it's quite actively pursued, and I would say looked in poultry farms, but a lot of times overlooked in pig farms. So for pig farms, it's important because of course, the volume and the concentration that they have of organic matter. The manure management is super important. Also, we need to consider the farrowing crate hygiene and, of course, the environmental impact. And when saying the environmental impact here, we're talking about we have ammonia emissions, water contamination, and so forth. So with cleaning, we can empower farmers. We as vets, we can empower farmers with the right tools. So to go from this to this, it's not straightforward. There are procedures, there are cleaning products, and we have to have a correct and nice equipment. So, and here, the go-to advice, of course, the first one is select the right cleaners. And for this, you need to focus not just on the price. You need to remember it's about efficacy first. It's about being safe. It's about being validated. And when saying safe, it's safe for you, for humans, safe for the animals, and safe for the environment. And saying this about safety, if you need less product to clean or disinfect and similar levels of clean disinfection, then that's a nice way to go. And of course, it's more than that. It's about technical support and also about using products that do consider the longevity of the equipment that you use. So for disinfection, for the next step, in the same breath, saying about equipping farmers with knowledge, because knowledge is power, of course. We as vets are consultants, but also we're educators. So we need to familiarize with disinfectants, and we need to know what type of disinfectants are there and why we want that, because we want to help farmers choose the right products. And for disinfectants, you need to also be a little bit, let's say, updated and use products that have regulation, like are in line and compliance with the European regulations. And of course, you do it with availability, with products that you know there will be there. And again, taking into account any safety status. So it's important for you because with this knowledge, we can train farmers. and we can guide about the dilution, the contact time, and the safety. And of course, this can be found in any leaflets. It's not that far. What separates you and your role is that you can consider the specific conditions of the farm. So which disinfectant and how to do it? The factors to consider, there are numerous, but here we just have a few. And of course, is that first you choose a disinfectant that is suitable for what kind of pathogens and what kind of risks you have on your farm. But not just that, you need to consider the temperature. And when saying this, we mean that it's product dependent. It has to be that there can be that you can heat up stables to achieve optimal effect of disinfectant. We also to consider relative humidity, and this is especially in case of fumigation. And you need to consider what materials are present in the farm, issues of corrosion, are there still residual organic material present, of course, because that will hamper the effectiveness of disinfection, and if there is a specific reason for disinfection. So if there's a specific reason for disinfection, then we need, of course, to modify the protocols to really answer this. And how to disinfect? We have the wet surface disinfection, we have the foaming, and we have fumigation and misting. And this sometimes can be because fumigation can be considered as spraying gas, and misting spraying aerosol droplets. And people sometimes say, isn't it the same? Let's call it that fumigation is more like wet fog, and misting is lighter the droplet, and it doesn't end up sticking to the surface. It mainly floats in the air, so it's dry fog. And of course, for that, you need to consider that safety is first. We're talking about disinfectants. It's quite toxic products if you don't do it just that. You do it correctively and using protective equipment. And of course, you work always with fresh solution. So things to consider here is the contact time. And of course, as said before, fumigation, for instance, if you have a defined place and you have this wet fog, it can stick to the surfaces, it can penetrate, and it can work quite well. But of course, as long as you can be sure that it can be an enclosed setting, quite a good enclosed setting. And of course, it's not just the contact time, it's dosage you need to consider. And also things about losing concentration because having a wrong dilution or having any residual liquid after cleaning, things to consider. And as we said before, always remember we clean first and then disinfect. It cannot be cleaning is the most important step in these two. You need to first clean and then disinfect. And disinfectants just have some, let's say, small an update, let's say, in a recap about the disinfectants. We have disinfectants and we have antiseptics. But indeed, so disinfectants can contain the same types of chemicals as antiseptics, but disinfectants are in far higher concentrations. So disinfectants is not something that you can use freely on your skin, not to see it like that. And disinfectants, the mode of action is straightforward, is about killing and inhibiting microbes. And it's, if you compare it with antibiotics, disinfectants is broad spectrum. They have a general mechanism of action, and the mainly is of intrinsic resistance. And as you see here, it's toxic for user. So the disinfectants, the drastic effects they have on the macromolecules, and they work with breaking down, of course, the cell, especially one, let's say, a point that they can work is they can go for the cell wall, or they can work inside. So they have multiple mechanisms as well. But if we are now to say a little bit about what kind of disinfectant we would want, is ideally we want a disinfectant that is broad spectrum, is fast acting, not inhibited by temperature, relative humidity, or anything, is non-toxic, is non-corrosive. I think we're asking a lot, but these are the ideal, so the characteristics of an ideal disinfectant. We want something that will really reach the totality of the area there and reaching everywhere in the farm, not just in the surfaces easy to be seen, but also reach in hard to reach places. And we need like something to be stable and pure in diluted form and soluble in water. And as you see, like there are many, the list is big and of course cheap. So having all this is let's say a wish list, and we send it to the companies and we hope to have this kind of products. But in the meantime, let's say we work with the product that we have and they are really good already. So we need to remember this is not, we really have good products and they are a lot of R&D at this stage working with disinfectants rather than with antibiotics. So for the types and classes of chemical disinfectants, there are many types, they're very diverse, and the toxicity can, of course, vary. And having said that, the mechanisms of action of disinfectants, they have numerous mechanisms. They can work on the membrane, as we said. They can attack on the proteins and denaturate them. They can have through oxidation or enzyme inactivation, and they can even damage nucleic acid, so they really reach to the core. But basically, we can break down is we can say they have three big mechanisms of action so that they affect or kill an organism. The first one is through cross-linking, coagulation, and clumping. And I would say a nice example for this is alcohol-based products and phenolic compounds. We have oxidation through oxidizing. We have chlorine-based for it and peroxygen compounds, and through disruption of the structure and the function. And this is more through quaternary ammonium compounds. So for the post-disinfection, what do? You always need to test, because if you don't measure, you don't know. And for testing of the efficacy of the procedure that you did is separate you, I would say, and it should be done, should be considered in your design of your planning for clinical disinfection. And for this, you can do either hygienogram through product plates, it's contact plates, agar plates that you just put it in, and then you get like you need to culture them and you get the results. It can be done through swabs and plating. It can be done through ATP monitoring. There are, of course, other tools as well, but what we need to remember is we need to measure. So monitoring and evaluation, I would say, is of special importance because it proves the value of our work. And having said that, we have biosecurity. We have the starting point, as we said before, that is quite complex. And it would be nice to have a tool to really showcase all the efforts you do, if this change, if it led to an improvement and all these things. Luckily, we do have such a scoring system from Ghent University. We have Biocheck that we have developed, and it is a scientific risk-based scoring system to evaluate the quality of on-farm biosecurity. It has a lot of entries. It has been filled in close to 100,000 times. So there are many farms in the system, as I would say is one of the biggest, if not the biggest, biosecurity database right now. So the way it works, it has, say, a checklist that is specific, not just for the animal species, but is also about the production type. So there are numerous biochecks for the different types of, let's say, poultry farming. For instance, there's different one for broilers, different for layers, different for breeder farms. And of course, you can feel free to visit like the web, and also have a QR code where you can check out the various tools. It's free to use, and you get the report in the end. So, and this is the report when you enter your data, and we have here an example for a pig farm. And as you can see, it has various categories, and you see in the upper part of this table, you have external biosecurity, and it's broken down as purchase of animals and semen, transport of animals, removal of manure, we have feed, water, and equipment supply, and so forth. And for internal biosecurity, what I want to point out is we have a clear score also for cleaning and disinfection. And if you can break down the score as, let's say, per column, you have first, you get your score, what that corresponds of how your farm did, how did it perform, and you can compare it with a country average, how is the other farms in your country is doing, and of course with a global average. So it's a nice way also to a little bit benchmark and see. It's not necessarily that important, but it's always nice to know where you're standing. And how can you use this biocheck tool? And you can use it. So if we say, for instance, we can go, it's not just applied in Belgium. We have been applying it in many countries. We have studies set up in, I think we miss only Australia. And for the rest, we have studies done. So it's a database that has included many farms throughout the world. And here, for instance, there's a study in India done by my colleague Pankaj, and there we made a small appreciation of what is the situation. So it's a situation analysis of cattle farms in India, in the province, in one province there, and we have 100 farms. And there, of course, it's easy. You can see more or less where they're standing as this province of India. And so what could be potential measures to be done to improve the situation? So it shows how important this tool can be. So for better biosecurity, of course, the hypothesis is that you have also a lower antimicrobial use and a lower antimicrobial resistance. Let me share some nice studies for that. For that, we'll start with one of the first papers done with Biocheck. Here we have a cross-sectional study. It was 95 Belgian breeder finisher pig herds. And what we did, we followed them through and to see any relationship between biosecurity and production and microbial treatment characteristics. So, and for the results, what we saw that the higher the external biosecurity or internal biosecurity, and that's the horizontal axis, the higher it was, as you see, the lower, in general, the treatment incidence is the antimicrobial use. So that's the more or less the antimicrobial use was. So the higher the usage, the worse in general it was the biosecurity. That's an important, let's say, message. And what also happened in this, so what we also have seen in this paper, in this study, that the stronger internal biosecurity, so the higher internal biosecurity, was linked with reduced disease treatment and also with lower usage. So for another study, we did a bigger study, and this time it was a cross-sectional study. This was done in more than 200 farms, farrow to finish, the big farms, and this was in 4 countries. It was in Belgium, France, Germany, and Sweden. And for that, we saw the biosecurity status. We tested with Biosec, and again, we got information for production and management characteristics. And plus, we interviewed the farmer. We got some extra insights. And then we analyzed, made associations with the biosecurity level. And for that, we designed a causal path to assess any statistical associations. And indeed, here are the results. And for this study, we had external biosecurity scores were linked with, so higher scores were compared, so were linked with a lower usage of antimicrobials. One thing to mention in comparison with internal biosecurity is that external biosecurity scores were in general higher when we compare with internal biosecurity scores, meaning that there are many, let's say, steps to be done in internal biosecurity. From the same farms that we had the previous study, we made an extra one where we identified the top farms. And these farms were like the top 15-20% of the sample had significantly lower antimicrobial usage and higher performance. So we focused in these farms. And so when we're seeing this, more or less to show it graphically, is, as you see here, the y-axis is the number of wind pigs per sow per year, and the treatment incidence was here. So treatment incidence is antimicrobial usage. So we focused in these farms. And the results were straightforward, that on average, higher level of internal biosecurity, especially in the category of cleaning and disinfection, were linked, like to be located. So it was a top farms, I would say. It had this asset. They really had high internal biosecurity, and surprisingly, it was also quite really high compared with the other farms in the category of cleaning and disinfection. Another finding, it was situated in a region with lower pig density. So having said that, so usually it was easier for these farms, of course. This is the ones situated in a region with lower pig density, were a lot of them top performing farms. But some top farms were also in high density areas. So there, for these high density areas, top farms, it was exceptionally high, the internal biosecurity scores. And they, besides that, they also had more vaccinations for respiratory diseases. So for another study, as you see, there is now that we have a lot of studies have done. Here we also introduced the element, I would say, of an intervention study that we did in 60 Flemish pig herds. And for that, we demonstrated that antimicrobial usage can be reduced without negatively impacting the production parameters. For this, we introduced a new way. We did an intervention program, and saying intervention, we meant coaching. So we now, coming as experts, are in line together with the farmer, and we do an action plan with them, how to optimize the management, biosecurity, vaccination strategy, and therapies, and how to really reduce antimicrobial usage. And we used the ADCAR methodology. And for this, we visited the herds and we screened it. And based on the findings, we made a herd-specific plan of action. So the results for coaching, we were able to improve biosecurity by 12%. And the majority, so it's noteworthy to say that the majority of the growth was on internal biosecurity. And as how much it went, as you see, the reduction was quite substantial. But also the production results was not bad, so it was not combined with negative results on production parameter. So we managed to reduce antimicrobial use and keep and actually even improve the production. There are many, just out of, let's say, keeping in time with in line, I will go faster in these slides, so bear with me. And you see similar results, I would say, quite similar results for broiler farms that we did. We improved biosecurity and managed to reduce microbial usage, keeping the production parameters quite okay. And if the majority of cases was also positively associated. We have done also a coaching strategy involving 2 countries. And as you see here, biosecurity on average this coaching led to a 7% increase in biosecurity and led to a 7% reduction on antimicrobial usage without having any negative effects on production parameters. And for similar, let's say, again, strategy, here is more, let's say, marked the results. Here are farms that want to go as farms that raise pigs without antibiotics. And you see by coaching, we achieved quite substantial results in reducing antimicrobial use and, of course, prioritizing biosecurity. But are these profitable? Like, is it good for the farm? This is quite important for the farmer and for you. And so here we did a nice intervention study where the intervention group actually did a lot of interventions. The majority, if not all, had to do about biosecurity. And of course, for some, it was also vaccinations, but the predominant factor was biosecurity. And as you see, yes, biosecurity led to a cost per sow per year that was close to €4. But accounting this expense, you also account a quite impressive, more or less, reduction in the use of antibiotics. And also taking into account it's a complicated model, it led up to a final net profit, as you see, per finisher per year of €2.6 and 42 per sow per year. So this information is quite important to keep in mind about the usefulness of biosecurity. A second study more or less addressed similar strategy with another model used, but still also here for that following these herd-specific interventions, we managed to reduce antimicrobial usage and actually had a positive economic impact. So it's the cost of these alternative measures did not outweigh the benefits of the reduced antimicrobial usage. So by summing this publication we did last year with Pankaj, we managed to show that now we have enough evidence and we analyzed peer-reviewed publications. And what we've seen, the majority of them are in pigs and followed by poultry. So here is a good audience for that. And we managed to have good news, so positive feedback from 22 out of 27 studies, where we showed the proven statistically significant association between farm biosecurity and antimicrobial usage. And as you see, most are directly linked with biosecurity, others with management, others with coaching, and with farm economics, and only 5 didn't manage to show a statistical association. And last, I have a study where we analyzed data from 14,000 pig farms across 10 European countries, and we collected this data for 3 years, and we assessed the implementation of cleaning and disinfection procedures. And I won't go through the questions. I want just to mention that we're talking about cleaning and disinfection is relevant in external biosecurity measures and also internal biosecurity measures. And the farms, and actually we have also back-to-back years here data for Belgium, Finland, Ireland, Italy, Netherlands, and Spain. And for these countries, you see the level of biosecurity is improving. That says a lot that farmers do the effort to improve. But when breaking down, of course, the questions, you see there are some green that we have, for instance, presence of hygiene log per country. This is quite, I would say, interesting results for you. And I invite you to read this publication that we did with Irina. But you see also some red or some orange. So it means there can be some actions there to improve, to higher biosecurity. And of course, focusing on cleaning and disinfection actions. And the same here are the questions done for the internal biosecurity part. And what is quite, I would say, not disappointing, but is the reality, is that checking the efficacy of cleaning and disinfection is not that high. And also about, I would say, the presence of a protocol for the cleaning and disinfection of equipment is not that high. So these things actually are parts that as veterinarians, we can do it and really increase and also showcase that we did something that is good and relevant. As conclusions, we say biosecurity is the basis. We need to address that veterinarians are essential to biosecurity and vice versa. And the cleaning and disinfection practices, we always do them together, focusing, of course, we start with a C, and we need to choose wisely. So not just for it's cheaper or it's more convenient, but just think about safety, efficacy, and availability and technical support, as we said before. And just let's say for key takeaways for the veterinarians is stay updated, attend these train the trainer workshops. They're really helpful. Educate farmers, embrace the One Health approach, showcase your cleaning and disinfection expertise, it's really important, this one, and of course advocate for biosecurity. And with that, I would like to thank you for your attention.
Thank you, Professor Elias. This is really a great overview. It's amazing the amount of data that you have shown and the impact of biosecurity. Thank you for that. I'm sure the audience found it interesting and insightful as well. As a reminder, the questions from the audience can be done via chat in the bottom of question and answers, and we'll be responding after Eileen's presentation. And thank you. And so now let's move to our next speaker. Please welcome Eileen Claes, who will be speaking about on selection and efficacy of cleaners to improve biosecurity in pigs and poultry. Eileen studied chemistry, the biochemistry specialty at the KU Ghent University. She conducted research on Campylobacter in fresh poultry meat at the veterinary faculty. Eileen also worked as laboratory manager and quality manager in a pig slaughterhouse during 4 years. And in February 2018, she joined Sea Lines as product manager technical support. Since 2020, Eileen works as the global technical support at Sea Lines and Ecoland Company. Eileen, please go ahead when you are ready.
Thank you, Elizabeth. Thank you, Elias, for the nice insights on the studies that are done related to biosecurity and cleaning and disinfection. So by seeing that data, I think I can share some extra insights on the selection and the efficacy of cleaners to improve biosecurity in pigs and poultry farms. So how do we select the best cleaner? There are a few parameters that we need to take into account before we can choose the right product for the right environment. So environmental aspect is quite an important thing. There are some concerns related to the environment, toxicity, risk assessment of products. So we need to make sure that we can reduce water consumption, and in that way that we can reduce the wastewater streams coming from the farms as well. The type of soiling is quite important as well. So in the animal production, we have quite a heavy soiling, greasy, sticky materials, a lot of fats and proteins due to the manure of the animals. So we need to make sure we choose the right product to remove all that organic dirt. To remove organic dirt, we need alkaline detergents. To remove inorganic dirt, we go for acidic detergents. Water itself has an impact as well. Do we use cold water? Do we use warm water? The hardness of the water is important as well to take into account. Formulated products, they have ingredients inside the formula that are impacting the water hardness, and that doesn't have an impact on the efficacy of the cleaning itself. Cold and warm water, it's depending on the application. For example, in crate washers, in hatcheries, or in slaughterhouses, there we have a very short cleaning time. Then the temperature of the water will have a huge impact on the efficacy and the results in the end as well. Then, of course, the surface. So we need to make sure that we know the type of materials that we want to clean. So do we want to clean metal surface, wood, concrete, plastic, things like that? We need to make sure that the products are removing dirt on every type of surface in the farm environment. And the application method. Do we want to foam? Do we want to spray? Do we want to do thermal fogging for a disinfection, for example? The application method is important as well. We, as Sea Lines and Ecolab Company, we really recommend the foam application, because foam is visual. You see what you do. And I'm quite sure if you foam an area that you will not forget any place to cover with product. And if you forget, I'm quite sure you will go back to cover it with foam as well. It's much easier to see it compared to a spray application. Foam can also give a longer contact time and a longer working action, for sure, if you have a good foam capacity of the product. A little bit of theory behind a cleaning product, because it's important to understand why we need a good detergent to get the good results and to be able to reach optimal results after the disinfection step as well. Like Elias mentioned, cleaning is the first step and the most important step. It is giving the biggest reduction related to microorganisms that we have in the farm environment. So one of the ingredients in a cleaner are surfactant molecules. So surfactant molecules, they look like here on the picture. They have two different parts. They have a hydrophilic head and a hydrophobic tail. The hydrophilic head will attract to water. the hydrophobic tail will attract to organic or inorganic dirt. So we have different types of surfactants. There are 4 different types: the non-ionic, anionic, cationic, and amphoteric surfactants. The different types are related to the charging of the head of these molecules. We need these molecules because they are responsible to penetrate in the dirt layer, to break down dirt layers in smaller particles, and to make it easy to remove dirt. In an easy way, they are the ones helping the farmer to remove the dirt, and they are responsible to make the cleaning process more efficient and more easy at the same time. One of the parameters that we need to take into account is the CMC, or the critical micelle concentration. It's a parameter that we check related to detergents. Like you can see here on the left slide, on the left side of the slide, we have the detergent molecules, or the surfactant molecules, that will populate the surface of a water solution. When the surface is completely populated, then they will start to form micelles. So here, this is a micelle. And that's what we really need to get a good penetration action, to be able to dissolve dirt and to break down dirt layers. Here on the right side of the slide, you see a graph. And that explains how important it is to pay attention to the right concentration, or to the instructions of use coming from the producer or the supplier of the products. When we add product in a water solution, we will slightly go down as we will increase the surfactant molecules. At a certain moment, we will have the critical micelle concentration, so the optimal concentration to get the best penetration action of the product. So here you see, by adding a certain dosage of a product, you lower the surface tension, so it makes sure that we can spread the detergent solution and that it can really soak every part of the surface. Here, another detail that I want to share is that we should not double or triple the concentration of our products. Once we reach the critical micelle concentration, we will have the optimal working action of the product. And if we add 1%, imagine this mark is here 1%, then it doesn't matter to double or triple it, because the working action of the product will stay the same related to the surfactant molecules that we have. The pH is another measure that we need to take into account. I mentioned before, we have different types of soiling, and different types of soiling require different types of products. That's quite important to know which product we need for which type of dirt. On the left side of the pH scale, we have the acidic products, or the acidic pH. For example, mineral deposits like rust, calcium, scale buildup, they are on the acidic side, so there we need an acidic product to be able to remove these types of stains or dirt. On the other side of the pH scale, we have the alkaline products. And then we talk about organic soiling. Can be proteins, can be fat deposits. So the heavy organic soiling that we have in poultry and pig farms, for example, think on manure. Then we need an alkaline detergent, and it can be, for example, a Kenosan that has a high alkaline pH that is very strong to remove these organic dirts. We did some comparative trials in the lab to see what's the impact of different detergents in the market on the efficacy of cleaning, on some basic laboratory measures, and also related to foam. As we are really promoting foam application to cover everything because it's visual, and to get a longer working action and contact time to reduce total cleaning time in the end, and to help the farmers. So here the laboratory measures were pH and the critical micelle concentration, like I mentioned shortly before. We did some cleaning tests related to the efficacy of the cleaning process in lab circumstances, so it's not the same as on a farm, but here it's really showing a dipping method and not taking into account a high pressure machine or a lot of water usage. So it's just having a metal plate with a soiling on top of it that we put in a solution. We dip in and out to see the efficacy of the product. We did that with a 1% dosage of different products in the market, and a 15-minute contact time. And we did the same study, but with the minimum recommended concentration on the labels and the technical data sheet of the different products, and with different contact times, so to see the impact of a short and a longer contact time. Then we also did some efficacy testing with a protocol where we were using a strong alkaline foaming product like Kenosan, compared to a cleaning protocol where they just use water and a high pressure machine. And the third test that was done was checking the foam creation, the foam capacity of the detergent with a Cita foam tester. It's a machine in the lab. I will show you a photo later on, where we tested a 1% concentration with a 15-minute contact time to see if the foam stays stable, and if we can recommend longer contact times to get the optimal working action as well. Here in the table on the right side of the slide, you see the different categories of products in the market that we were testing. So mild alkaline, soft alkaline, strong alkaline cleaners, an acidic cleaner, and then our Kenosan as a strong foaming alkaline cleaner as well. The first basic measure, but saying something about the cleaning efficacy, is the pH. So the pH was measured in the lab with the different concentrations of the product. So here you see that the acidic product, the red line, is showing an acidic pH. That's quite logic. That's a product that we need to remove inorganic dirt or scale mineral deposits. Then the alkaline products are showing quite some similar pH values, even though you need to keep in mind that the pH is a logarithmic scale. So even if there is a small difference, the difference is bigger in reality. And here we see the soft alkaline product shows quite a big difference related to pH as well. What is the pH telling us? If you have a high alkaline pH, a strong alkaline product, then we know it will have a good degreasing activity. So it's good to remove fatty deposits in the farm environment. It's of course not only the pH telling us something about the efficacy, but also the CMC, or the critical micelle concentration. Remember here that photo, the molecules, the surfactant molecules that we have inside our detergent formulations, detergent products, that are able to form a micelle, and that's what we need to have a good penetration action to be able to dissolve dirt, to break down dirt layers. If we zoom in on the graphs, then we see quite a difference between the different products. What does it say? So the blue line is about our Kenosan. It shows quite a strong decrease of the surface tension, and it reaches the critical micelle concentration on a quite a low dose as well. So it means that we don't need a lot of product to have the optimal working action of the product. You see here for the other products that they need more product, a higher concentration, to get that optimal micelle concentration or critical micelle concentration, and to give the optimal penetration capacity. So here we can also link that back to environment. The lower the amount of product we need, the lower the impact on the environment anyway, and also for the farmer related to cost. And the lower the product consumption, the lower the cost for the farmer will be. So here we see that we have a very high penetration capacity because of the low critical micelle concentration. Then related to the cleaning efficacy trials, the first one was done with 1% concentration and a 15-minute contact time. So here, the most important message for me is that an acidic product is not able to really remove a high amount of the organic dirt. The left side of the slide shows a different type of soiling compared to the right side. On the left, we have a very sticky and greasy soiling. It's coming from beef grease and pork brains. So very fatty soiling that sticks on the surfaces. On the right side, we have a combination of buttermilk and raw milk. So it's more a mixture of organic and inorganic dirt. That shows the results here on the acidic cleaner. So here, acidic cleaners are used to remove inorganic dirt, and we have that here with the milk combination. That's why we see higher removal of dirt compared to the sticky, greasy organic soiling. On the other hand, we see that the soft alkaline is not strong enough to be able to remove the soiling, the greasy soiling, and then the mild, strong, and the Kenosan are able to remove biggest part of the dirt. Here you see there were 3 tests done, all at 15 minutes contact time. Here you see for the strong alkaline and Kinosan that they remove between 90 and 100% of the dirt. So this is showing the importance of the cleaning step to remove the highest number of dirt before we go to the disinfection. For the butter and raw milk combination, so combination of organic and inorganic dirt, we see that the different products are showing a better efficacy, and that's just related to the type of soiling we have. So here again, the importance of choosing the right product for the right type of dirt. Then the same test that was done with the minimum recommended dosage of the producer or the supplier of the product. So the dosage that is mentioned on the technical data sheets and the label. So you see here for the mild alkaline, it's 0.3%, for the soft one, 0.4%, for the strong alkaline, 1%, for Kinosan, the minimum dosage is 0.5%. So that's something to take into account. And then the different colors in the graphs are showing the different contact times. Blue is 5 minutes, orange 10 minutes, and the gray bar shows the 15-minute contact time. Here again, it's important to follow the recommendations of the supplier. Even though with the minimum concentration of the mild and the soft alkaline, we are not able to remove the biggest part of the greasy, sticky soiling that we have from the beef grease and the pork brains. Only the strong alkaline products are able to remove between 90 and 100% of that type of soiling. An important side note here, for Kinosan, you only need half of the concentration compared to the strong alkaline. So related to product consumption, cost for the farmer, it makes quite a big difference. On the combination of the buttermilk and raw milk, we see better results with the mild and the soft alkaline, again, depending on the type of soiling, the different type of dirt that we have. And then the strong alkaline and Kinosan are showing quite nice results. Here you also see the importance of the contact time. Make sure you give the product time to work and to help you to remove the dirt. Then the foam comparison, that's the third test that was done in the lab. You see the photo of the Sita foam tester that we have in the lab. That's the machine that is used to check foam creation and to check stability of foam as well. So that's quite important for us, as we recommend foam for a longer contact time and a better attachment, for sure on vertical surfaces like the walls. We really want to have a good penetration action over there as well. So then we need a good stability of the foam and a high foam creation. Here we see that the strong alkaline that was giving quite good results related to cleaning efficacy has a lower foaming profile. So here foam is quite important to get that longer contact time and that better attachment. So we see quite some differences between different products in the market related to foam creation and foam stability. Then the last one related to the efficacy, if we use a detergent and water, compared to just using water to clean a farm environment, a poultry barn or a pig barn, then we can show quite some difference as well. Again, the two different types of soils. So on the left side, the greasy, sticky soil from beef grease and pork brains. And on the right side, the combination of buttermilk and raw milk. So a combination of organic and inorganic dirt. Both tests were performed with a 1% concentration of Kinosan and a contact time of 15 minutes. For water, we can just talk about the contact time of 15 minutes. For the organic, the sticky, heavy soiling, the greasy soiling, we see that water is only able to remove around 30% of the dirt. With Kinosan, we see that we can almost reduce 100% of that dirt. And that's important related to biofilm as well, because microorganisms are hidden in biofilm and more difficult to remove. So here, it's very important to have the high removal of that sticky, greasy soiling. On the butter or the milk combination, we see a higher efficacy of water, and that's really because of the type of soiling we have. So we can reduce quite a high amount of dirt over here. And with Kinosan, we can reduce around 95% of the dirt, what is quite a lot as well. Why is it lower here compared to the greasy one? Because we have inorganic dirt over here as well, and therefore we need an acidic detergent. So if we take an average of these two figures here, then we can say that Kinazon is 40% more effective in removing different types of soiling compared to just using water. I think that's an important message for the farmers that are not using or not investing in a detergent or a soap to do the cleaning step. A little bit about the application. So that's here showing again, it's a short summary on how the detergent molecules or the surfactant molecules are helping to break down dirt layers, to dissolve the dirt and to get small particles and to make it easy for the farmer to rinse away with a high pressure machine and water after the contact time was respected. That's how an optimal cleaning process should look like. So it's a bit of repetition from Ilyas's slide. First step is dry cleaning. Remove all the organic material before using water and soap. Then we can apply foam, a detergent, in a foam application. For Kinazon, it's 1 to 1.5% with an optimal contact time of 30 minutes. After that application, we do a high pressure rinse with clean water. Otherwise, we recontaminate the environment. Then we let it dry. We remove water and we let it dry, and that's very important to make sure that we don't dilute the disinfectant afterwards. When everything is dry, we can apply foam application again. The disinfectant can be Viruset, for example, 0.5%, and we let it dry before we prepare the barn. Like Ilyas mentioned before, testing, monitoring the efficacy of the whole process is quite important. I'm not saying that you have to do it every time, but doing it on a regular basis can really help to show that the cleaning and disinfection process is paying off, that all the time and the cost, the effort that you put in cleaning and disinfection processes are bringing you the results that you want to have. The center circle is an important topic to keep in mind when we talk about cleaning as well. So here, just to show, if you just use water, you will have quite a long contact time for the water to soak. And even then, you will not be able to really break down dirt layers because you don't have the surfactant molecules. You will need a lot of energy, so coming from the high pressure machine, a lot of water coming from the high pressure machine as well, to be able to remove all the dirt. And it will take quite a lot of time as well to get the farm clean. If we use a regular foam product, then we can increase the contact time because every product has his own contact time. By increasing that contact time, we let the product work and help us to remove dirt. So we will need less energy, less water, and the total cleaning time will be lower or shorter as well, because the product is helping us. And if you use a premium detergent or for example, Kinazon, then you can increase the contact time even more. And that means that we can reduce energy, water consumption, and total cleaning time. I will show you some figures that come from studies done in the lab and field trials as well, done in dairy, pigs, and poultry sector, where we can show a reduction of water consumption up to 30%. And this topic becomes quite important in different parts of the world where we have some water shortage, and also related to the environmental impact. The lower the water consumption, the lower the wastewater stream as well, the lower the impact on the environment. And we can show a reduction of total cleaning time up to 24%. And this is really showing a reduction of costs for the farmer as well. Foam application, like I said, visual, you see what you do. Longer contact time if you have a good foam capacity, a foam that sticks where you apply it. A better attachment on different types of surfaces. For sure, the vertical ones, or like tubes, are important as well, that you can cover them with foam and that the foam is cleaning them as well. And it gives a low product consumption as well, as you really see what you do, so you don't go twice over a certain surface. Low dilution, 1 to 1.5%. Sticky and long-lasting foam. It stays stable up to 60 minutes. That's what we see from trials in the lab. We recommend an optimal contact time of 30 minutes. It's easy to rinse. What do we mean? That it does not foam again or foams more when you start doing the rinsing step. So you can just rinse away the chemical and the dirt. Strong adhesion on different types of materials, metals, wood, concrete, plastic, and so on. Foam does not dry out, at least we can guarantee a long contact time. Of course, if you clean something outside and it's dry, warm weather, you should not leave it there too long. You need to make sure you can get the contact time and then you rinse it. Good penetration capacity, and it's safe for materials, so we have a good material compatibility, and we can say it's non-corrosive for the farm industry. Related to the penetration capacity, something that we like to talk about in the field to show the farmer the efficacy of the product is that the foam turns brown. When you apply the foam, it should show a brown color, because then it's really penetrating in the dirt layers and dissolving dirt particles, so helping you to remove dirt. If the foam stays white, then it's just a layer of foam on top of the dirt layer, not breaking down dirt layers or not dissolving dirt particles. Here's some examples from the field where you see the difference in the color and also in foam capacity. So on the left side, it's a more liquid foam. It does not stick on the higher levels. On the right side, you see the Kenozan that shows a nice foam capacity staying there for quite a long time. Related to product consumption, an easy thing to do in the field is using a foam lens, putting the same amount of product in the foam, in the bottle of the foam lens, and just setting the right concentrations to compare the product consumption. Here, these pictures are showing the seconds that we put foam with 500 milliliter of product. So for one product, it was 63 seconds. For another product, it was 74 seconds. And for Kenozan, 105 seconds. So what does that mean for the farmer? That they need less product to cover the same area compared to some competition products. And that's something easy to check and having a huge impact for the farmer related to product consumption and cost in the end as well. How can we validate cleaning and disinfection? First is a visual check. Always good if someone external can do a visual check. For example, you as veterinarians can be a good person to do a visual check as well. Because if the farmers has to do it themselves, they did the cleaning and disinfection, they know their farm, sometimes they lose the attention for some critical points. So it's always good if we as biosecurity advisors or the veterinarians or technicians can go there to do a visual check. And if you still see manure, you know there is still a contamination. Gas tissues can be used to do a check as well. You scrub a certain surface, and if they stay white, everything is removed. If they show dirt particles or brown coloration, then there is still some biofilm. ATP measures, like mentioned by Ilias, can be used as well, even though you need to have some historical data over here to be able to compare. Because in the food industry, it's quite easy. You have smooth surfaces, easy to clean and disinfect. So here it's easy to use. In a farm environment, it can be more tricky because we have porous surfaces, and there we really need to build some database to be able to compare values of the ATP measurements. Biofilm test kits can be used as well. It's kind of an oxidation product, showing some foam if there is still biofilm. If they don't show foam, biofilm is removed. To validate disinfection, swabs and Rodac plates can be used as well to check total bacterial count, or for the swabs, you can go specific for Salmonella, Listeria, Campylobacter, or things like that. So this can be used after cleaning as well, but then it's important to check after the disinfection step as well. If the cleaning step is done, then we can start talking about disinfection. We should not start talking about disinfection if we don't clean. We cannot disinfect shit. Yes, we can, but then you don't disinfect the surfaces below the manure of the animals. So here, important to keep in mind to select the right disinfectant is the biocidal regulation. So they need the right registration for the right application. That's something you always need to check. PT3, for example, in Europe, PT4, PT5 are different applications. In other regions of the world, you have your specific registrations as well. So you should always check before choosing the right product. Both broad spectrum efficacy, we want to kill bacteria, virus, fungi, yeast, spores. We want to kill as much as possible. So efficacy testing is important to prove the efficacy of the products. We need to keep in mind that we have quite some challenges in the animal industry. So we need to choose the right disinfectant to fight against African swine fever, to fight against avian influenza, to fight against different challenges that we have in our industry as well. And then there are some studies that show if you use disinfectants according to the recommendations or the instructions of use, so that means not overdosing and not misusing, then it is quite difficult to create resistance of microorganisms against formulated products. So here I really want to put the focus on formulations where we have different active substances. A microorganism, it will be very hard for a microorganism to adapt to all the different active substances in a complete formulation. So you should not worry too much about resistance and using disinfectants. And this picture here on the slide shows the importance of the cleaning step again. Sorry for repeating, but that's the main message here. Cleaning is the first step and the most important step, removing more than 90% of the dirt and the soiling. And then we can go for an optimal disinfection where we can reduce as much as possible. Of course, we cannot go for a 100% reduction. That's not our goal neither. We should have a certain microflora present, but we want to reduce the pathogens as much as possible. And here, just a side note, that's quite important to keep in mind. For biocides, we need to show or to prove log 5 reduction for bacteria, log 4 reduction, for example, for viruses and yeast. So here you need to keep in mind, if you have 100 million microorganisms left in the environment after the cleaning, then with the log 5 reduction, you can just remove 5 zeros from that 100 million value, let's say. So you can do a disinfection, you will have a reduction, but you cannot expect the same results as when we have values of 1,000, 10,000 microorganisms left in the environment after the cleaning step. So then we are at the end. So conclusions and takeaway messages from my side. Here I just want to repeat what we can show when you use an optimal cleaning product to reach optimal results at the cleaning process and to be able to go to an optimal disinfection. Foam. The foam capacity of the product is important to get a contact time to cover all the different places and to have a good attachment to get good removal of soiling everywhere. We can remove more than 90% of the dirt when we use a detergent or a soap compared to water and of course compared to nothing. We can reduce water consumption up to 30%. Related to wastewater streams, related to water consumption, where we have water shortages, and also related to the impact in the environment. Using Kineson is 40% more effective than just doing cleaning with water and a high pressure machine. We can reduce 24% in average in time consumption for the total cleaning process when we use a soap compared to just using water. And then we can be 50% more efficient in removing and in reaching the good results by the cleaning step. To go to the disinfection step as a second step in the whole protocol to achieve an optimal reduction of the infection pressure that we have. So I want to thank you for your attention and to be here. I hope it was interesting for you. And if you have some questions, then you can always contact us.
Thank you, Lynn, to give us these practical insights about the relevance of the cleaning step and how to select a good detergent. Thank you very much. And yes, we have a lot of questions in the chat. So I will start making questions to you and to Elias. If you can switch on your camera and your audio, please, I will address these questions. Thank you. So first question is for you, Eileen. Question is, in your opinion, what is the main mistake that people make during the cleaning process?
So for me, the first thing is not using a detergent. And if they use a detergent, then it's important to check the concentration and the contact time if they follow the instructions of use to get the most optimal results in the end. Another thing that can be related to mistakes is the equipment that they use. So they should make sure that they use the proper equipment to get an optimal foaming capacity of the product or to have a good distribution of the product. And important related to the equipment is that they need to rinse the equipment after every use to maintain the equipment and to make sure it's working properly.
Very good. Thank you very much, Eileen, for the answer. Elias, this question is for you, and is what is the essential topic on which veterinarians should be trained to ensure optimal hygiene in farms?
Yeah, so I think I'm biased, I'm the chair of biosecurity, but the answer is biosecurity. So we really need to think that by investing, let's say, the topic to be trained to ensure that you really reach the level needed for your farm and showcase your, expertise and everything that you know is through biosecurity. Through there, you're able to do your vaccination strategies, your disease surveillance, pathogen identification. So like it's I would say the starting point, and it's essential nowadays in the 21st century.
According to your experience, do you think vets are well trained on cleaners and cleaning and disinfectants and all this stuff, or we need more?
I think we need to, because it's used many times as a straightforward thing, and you know it and you understand it, and why should I care? It's misperceived as simple, which is a set of simple steps, but it's quite complicated exercise to do. So indeed, you need to invest in training. And there are nice, nowadays we do have nice training sessions, and also today is a nice opportunity, I would say.
Very good. Yeah, that's why we are here, I guess. Very good. So, Elin, this question is for you. Does it have an advantage or even a disadvantage if the foam is left longer, example, overnight?
First of all, I don't think there is a product existing that can keep foam for a whole night. That's the first thing. So an important thing is to check the foam capacity of the product. If you have liquid foam, then for sure the contact time will be quite short. And then I should not leave it overnight, because you let it dry and the dirt will just stick again to the surface. So you should respect the contact time that we mention on labels, technical data sheets, to get an easy removal and an optimal removal of the dirt. Otherwise, it just reattaches on the surfaces and you need to start over again. Or you start doing the rinsing, but in the end, you're just doing the cleaning step with water and high pressure. So follow the contact time recommended by the supplier. That would be my main message, because leaving overnight will dry out and reattach dirt.
There is another question for Elias. Is there any detailed protocol of cleaning and disinfection in an African swine fever infected farm?
Yeah, so for that, there is, let's say, a place that you will find the detailed. So there are countries that have, for instance, Belgium has issued from the federal agency, they have issued a nice, it's a document with guidelines on how to do it, including also a protocol. But I would say it applies to Belgium, can be extended, but we shouldn't just say, we have one and we just apply it wherever I am. We should also consider the specific setting. Having said that, also I want to mention that it's more and more in the legislation, even in the European Commission, it's mentioned the need to have this biosecurity plan in case of African swine fever. So I would say first check at your country, what is out there, see what's applicable, try to do it, of course, and be one step ahead and make sure it helps.
Very good. I don't know, Elaine, you would like to add something, because you were working a couple of years ago in protocols, updating protocols as well for African swine fever.
Yeah, so related to African swine fever, we should not only talk about barn hygiene or the buildings. We also need to take into account water treatment, because we know the virus can spread via drinking water as well. So checking drinking water systems, drinking water quality can be important in that case as well. Transport hygiene is a very high transmission risk over here for even influenza, for African swine fever, for sure, with all the transport we have nowadays. So there, I think today we miss the proper follow-up of the protocols. There are protocols, and of course it's easy to say, it's more difficult to do in practice. I know that, but I think we should focus on transport as well if we talk about African swine fever. Make sure they do cleaning of the trucks, and cleaning not just with water, but using a detergent as well. And then, of course, doing a good disinfection step to ensure that we remove possible presence of African swine fever. And then, if I can add something more, it's in fact many measures in the biosecurity program. Entrance hygiene, very important as well. Take care of, minimize the visitors or the persons coming to your farm as much as possible, because every person that enters can be a transmission route or a vector for transmission. Make sure that you have clear guidance in the hygiene log, that they know how to wash and disinfect their hands. It's an easy thing, but some studies were showing many mistakes against hand hygiene as well. And I'm quite sure if we ask 20 different persons to wash their hands, that we can find 20 different results. So it's a very easy measure, but many mistakes are taken. So even for hand hygiene, using a soap first to wash, dry your hands, and then disinfect. In fact, it's the same principle as cleaning a building or equipment or things like that. Clothing hygiene and boot hygiene is very important as well, because you can transmit pathogens or you can spread them from one building to another building if you make mistakes against entrance hygiene.
Thank you. There is another question. Well, there are 2 or 3 questions around the same. I will summarize, which is the best validation tool to ensure the efficacy of the cleaning and disinfection procedure in the farm. Any of you, because you both presented the similar slides, so who wants to answer first?
I just want to say one final, let's say, remark about the previous question, just to say, I'm thinking about, okay, not specifically the plan, what you can do. And I know it's biased and we are from UGent, but doing like doing the biocheck and seeing where you are, it certainly will make it easier and more straightforward for you to set up your biosecurity plan. So doing these tools, not just biocheck, but saying this because that's the one I'm familiar with, it's really important. So try to include it in your
and that's what we try to recommend to our customers as well, because then they can find the right priorities to work on, because you cannot change 10 things at the same time. We are doing several things out of habit, and it's not so easy to change habits. So with filling in the biocheck, you can point out the priorities and make an action plan where to put the focus first, and then step by step improving in general.
And just to say a small thing, it's not a straight, let's say, winner in the question that you said. It's not that you just do one. It's out of, you need to think about the resources, and for ATP it's cheaper, obviously, but of course reliability for cleaning is okay. For disinfection, I wouldn't say so. So you need to think a little bit about how fast you want the results, what is your budget, how reliable you want your results to be. I don't know if it's not a diplomatic answer, it's honest. So you need to think it through.
Yeah, I agree with that. There are many tools that can be used. So it's up to your own choice, but also make sure, that you measure something, because if you, like Ilya said before, if you don't measure, you don't know. And if you put a lot of time and effort in these cleaning and disinfection processes, then it's nice to see that it pays off and that it gives you some return in the end. For me, if you really want to know what you still have in the environment, swaps are the best method to have an exact number. But even then, you have some mistakes. You should not swap the wall or the floor, the easy to clean and disinfect surfaces. You should really search. In the end, you should try to find something that you don't want to find. That's a bit the message. So you should go to the difficult or the critical places to check if everything is removed over there.
There are many questions. I will make the last one. Sorry. Is it effective to use alkaline detergent, then switch to acidic detergent and swap between them? What is your experience, Eileen, on that? What is your recommendation?
So we see in protocols where we have some challenges. So for example, salmonella that is staying there, a persistent salmonella, for example, then we recommend to use alkaline and acidic detergents. Why? Because you change the pH, and that puts already a pressure, a microbiological pressure. But on the other hand, you remove different types of dirts. And it's possible that you have like a biofilm that is not really visual. And by putting an alkaline product, of course, never mix them together. Right? You first do the alkaline product because normally in a farm environment, the highest dirt level is organic material. So first the alkaline, then you rinse, then you put the acidic product to remove scale buildup or mineral deposits, and that can have a positive effect for sure if there are some challenges inside the farm environment. Yeah,
okay.
for
Thank
sure.
you very much. Thank you very much. So unfortunately, we are running out of time. There are some questions related if we are going to share the presentations. In the closing slides, you will see an email address that is animalhealthcommunications@ecolab.com, animalhealthcommunications@ecolab.com. You will see in the closing slide. You can send us an email and we will share with you any presentation or any of the questions you have done in the chat and have not been answered. We will reply to them. So thank you, Lynn. Thank you, Elias, again. Thank you for everyone for joining our webinar. We hope you found it content valuable. If you have further questions, please don't hesitate to contact us in the email address, as I said, you can see here in this slide. Note that the certificate of attendance of the webinar will be available upon request. You can ask in this email as well. And please take a few minutes to share your input on the survey that will pop up soon, so we can continue improving for future events. Once again, thank you very much, and have a great rest of your days. Thank you.